Hey everybody, this is Mrs. Anderson, and I am working now Section 5 of Master Math Mentor, and we're doing Section 5 of the classwork. So I've already done this video one time, but then made a mistake, so I'm going back through it, but I'm not going to redo all my work, so I just kind of covered it up, and we're going to talk about it, okay? So pause it, copy it, and make sure you're listening, okay? Don't try to race through it. So the first thing is that these are going to be called piecewise functions. All right, so piecewise means that there's two things going on, and if we look at this function over here, and we look at the one line, okay, so that's going to be x equals 1. We have some sort of parabola going on here, 1, 2, 3, 4, and there's its y-intercept. So we have something like this, and then on the other side, we have something that's looking like this. Okay, again, totally rough sketch, all right, because this is a line with a slope of -3, and it had a 1 as an intercept, so this is very rough. But you can see that here we have the equal sign, so we're going to have a solid dot, and here we're going to have an open dot. You don't need to graph them, it's just so that you know what this looks like. So what we're going to do is investigate this from the left and the right to see what happens. So what I did first was I looked at it from the left side, and I just plug in the 1. It doesn't matter that it says left, just plug in the 1, and I get -3. And then I'm going to look at it from the right side, and I'm going to find the value is -2. And this is just like the graph limits we did. Well, these two numbers don't equal each other. So therefore, that's what these 3 dots are, okay, when you want to go a little quicker. The limit as x approaches 1 of the function does not exist. All right. Now we're going to look at the second example. We have a quadratic, we have a point of 2, 4, and we have a cubic. Okay, and again, this point means 2 is the x value and 4 is the y. So I would put a solid point if I was graphing this. So I look at the left side, I plug in the 2, and I get 6. 2 squared is 4, plus 6 is 10, minus 4 is 6. I look at it from the right side, and I also get 6. So they equal each other. So the limit as x is approaching 2 is 6. And you'll notice that this value, again, the limit doesn't equal the point, and that was okay, because limits have to do with looking from the left and the right, that you're converging on it. It doesn't mean the y value is that. All right, so we want to really keep that in mind. Our last one, and where I made my mistake the first time, because I wasn't paying attention to the equations. These are two totally different equations, but because they have the same denominator, I managed to repeat the numerator, which was a problem. So if I put in -3, I get -3 over 0, and here I get 1 over 0. So that means I now need to go back to that section where I check for the positive infinity, negative infinity values. So when x is -3.1, meaning it's just to the left, I have a negative on top and a negative on the bottom, which is a positive value. When I look at -3 from the right side, I'm going to use the right side equation, the greater one, and I'm going to get a positive and then a positive again. And over here I put a 2.9. So I said x equals 2.9 for this situation. And the reason I write that down is because a lot of times I forget. I'm in a rush, I forget what number I picked, and so to help you take a breath, write the correct number down. I get 2 positive infinities, so that means that the does not exist is going to happen because they are the same, and the reason is they're both infinity. All right, so that's section 5. Make sure you have all this stuff down before you head off into the last few sections. Best of luck.